Good morning, everyone. Today we are going to start with introduction of systems. So if you are talking about any of the physical system, it is nothing but it is interconnection of some of the components or devices or many a times subsystem, right? So if you are having any system, this system will be taking the signal as the input, will processing this signal and will be generating a signal as the output, right? So this is an example of a discrete continuous time signal where we are going to give the continuous time signal as an input. This system will be processing the signal and will be generating a continuous time signal at the output. So here we can view every system as a process by which input signals are transformed by the system and resulting in an output signal. But in mathematical terms, we can simply say that a system is nothing but set of interconnected operations. Right? So physically our system is the interconnection of components, devices and subsystems. But here in signals and systems, we will be representing each of the system in terms of mathematical expression. And here we are having nothing but a system is a set of interconnected operations. Right, so this system will be doing what? This system will be taking the signal as an input. Here we have represented a continuous time signal. Xt is the input signal, and this system will be generating an output signal, that is yt. So here we can say that this yt is nothing but the transformation of the input signal xt that we have given as an input. Similarly, if we are having a discrete time system where the input signal will be a discrete time signal xn, this system will be transforming that signal xn and will be generating an output signal that we will be representing as yn. So here this yn is nothing but the transformation of your input signal xn, right? Just a minute. Let me introduce one or more slides over here. Okay, so let us take for an example, we are having a system in which we are having one resistance that is connected to one inductor, and here we have applied a voltage source Vt, right? So this Vt is nothing but this is the input signal, and due to the application of this input signal, one current It will be flowing through this circuit. Now if I want to write the expression for this It would be nothing but let us say this resistance is represented as R, this is inductance that is represented as L, and if I am going to write the expression for this circuit, that will be nothing but resistance multiplied with the current IT plus L into dit over dt, and that is equals to the voltage Vt. As we have decided that this voltage is the applied input voltage, and by the application of this input voltage, some resultant current is flowing in the circuit. Therefore, The input signal over here is Vt, and the output signal that will be flowing through this circuit because of the application of this input signal is It. And this is a mathematical expression that is defining the relationship between the input and the output. So here we can see that this is nothing but our physical system, and this is the mathematical expression that is defining this system, right? So till now we have seen that a system is nothing but it will be processing the input signal and will be generating the output signal. And here in signals and systems, we will be considering each and every system in terms of mathematical expressions. Now, coming to the properties of the system. We may have a number of properties associated with each of the system. Among them, the first property is the memory, right? And based on this property, we may have our system that can be a system with a memory, or our system can be a memoryless system. So a system is said to be memoryless if its output for each value of the input signal depends only on the input at that time only. So the output of the memoryless system is independent of the input applied before or after that time t0. If we are considering the time t0, whatever is the value of the signal, let us say it is xt0, the output of the signal will be dependent only on the present value of the input signal, and it may not depend on the value of the signal that is applied before or after this time t0. So such type of system we will be considering as memoryless system. One of the important example of a memoryless system is our identity system. In identity system, here we have taken the identity system for both, that is, this one is representing the identity system for continuous time system, and this is identity system for discrete time system. An identity system is a system that will be generating the output that is same as the input that is being applied to the system. So such type of systems we will be calling as the memoryless system. Here this input, the output yt is dependent only on the present value of the signal, input signal applied over here, that is xt. Similarly here in this discrete time system, the output yn is dependent only on the present value of the signal that is applied over here, right? Example of a system with memory. Previous we have discussed the memoryless system, and here the system that we are going to study is a system that will require memory. So here you can see the expression of this system yt is equals to x of t minus 1. Here this output signal is dependent on the previous value of the input signal. And if a previous value is considered over here, that system is considered to be a system that will require a memory. Similarly, another example given over here is an accumulator. Here, this is a discrete time system. Output yn is dependent on the value of the input signal that are summed up from k is equals to 0 up to k is equals to n. So here the values, n number of memory elements will be required for reserving the values of this xk, and all these values are added up together so as to give us the output signal over here, right? So here the signal output yn is dependent on the present value of the signal, that is xn, but also it is dependent on x0, x1 till xn. Xn is the present value, but from x0 to x of n minus 1, these are the previous values of the input signal, and therefore this system is a system that will require some memory. Based on these properties, we may classify our system as the static system or a dynamic system. A static or memoryless system is a system in which output at any time is dependent on the input at the same time, but not on the past or the future inputs. In other case, this type of system is said to be dynamic or have a memory. So here we will remember one point, static or memoryless system that will not require any memory. That means it is independent of any of the previous values of the input that are being applied to the system. Whereas a dynamic system or the system that will require memory is a system in which present values of the input as well as past values of the input can also be considered. So here are some of the example. One system is given over here where yn is equals to n times of xn plus bx cube n. Here you can see that this output yn is dependent on the present values of xn as well as cube of the present value of xn. Therefore, we will say that this system is a static system or a memoryless system. Another system that is given over here is yn, that is equals to summation from k is equals to 0 to n hk x of n minus k. So for calculating the output, we may have to calculate the values of x of n minus k, and the value of k is ranging from k is equals to 0 to k is equals to n. That means x of n minus 0, x of n minus 1, x of n minus 2 up to x of n minus n. So this is the present value of the input, whereas all these values are the previous values of the input. So this type of system is considering the previous values of the input, and hence this system is a system that will require memory, and hence this system is a dynamic system. And here you can also see that the values or the number of memory elements are required are from k is equals to 0 to n. So we have to store the memory for n bits only. Therefore, this system is a finite memory system. On the other hand, if you look into this expression, here yn is equals to summation from k is equals to 0 to infinity hk x of n minus k. Here again, for calculating the output, we may consider the previous values of this signal xn. But here we may require infinite number of memory element for storing these values of the input. So this is again a dynamic system, but this system will require infinite memory. Right? So till now we have seen that we may have the first classification of the system, first property of the system, that is based on the memory, and based on that our system can be considered as a static system or a dynamic system. A static system is the system which will not require any memory, whereas a dynamic system is a system that will require some memory that is dependent on some of the previous values of the input. A static system will dependent only on the present value of the input that is being applied to the system. Coming to the second property, that property is invertibility. And based on this property, we may classify our system as the invertible system or non-invertible system. A system is said to be invertible if distinct inputs applied to the system leads to distinct output. We can say it another way, as a system is invertible if by observing its output we can determine its input, right? So here one example of discrete time system is given over here. This is our original system to which we are going to apply an input signal xn, and it is generating an output signal yn. Okay, so this output yn is generated, and now if we may design a system that we will be calling as the inverse system, to which we are going to apply the output of this first system, and this inverse system will be processing our signals so as to give us an output that is equals to the input applied over here. If this is possible, then that type of system is said to be invertible system or inverse system, or if it is not possible, then that type of system is said to be a non-invertible system. Let us take for an example, one system is given in which output is twice of xt. Right, so this system is doing what? It is simply multiplying whatever is the input being applied to this system, it is multiplying it with a constant 2. Let us see whether this system is inverse system or invertible system or not. So here you can see that this xt is being applied to this system yt, which is doing nothing but multiplying this input signal with 2 and generating an output yt. This yt is equals to twice of xt as being given over here, right? Now we are going to implement one inverse system, which will be doing what? Whatever is the input signal going given over here, it will be dividing it by 2. So let us say that it is generating an output signal zt, and if we are going to apply this yt to this system, this will be doing what? Yt divided by 2, which on the other hand we have seen that this yt is nothing but twice of xt, and if it is being divided by 2, what we are going to get? We are going to get xt, as you can see over here. So you can see here in this system, we are able to recover the output by applying the output of the first system or the original system to inverse system, and this type of system are said to be invertible, in which we are able to generate or recover our original signal back, right? Let us take for another example. My output yt is sin t. So if somebody asks you whether this system is invertible or not, so we can see over here that we may have different possible values for yt. Let us say I'm going to get yt equals to 0. Now by looking at this value of yt that is equals to 0, I may not be able to tell what was the value of the t applied over here, because we know that sin t is having a value of 0, at 180 degree, at 360 degree, and so on, right? So by looking into the value of yt equals to 0, we are not able to tell what is the value of the sin t applied over here. So this system is our non-invertible system. Coming to another property, this property is causality. A system is causal if the output at any times depend only on the input at the present time as well as input applied previously. Such a system is often referred to as being non-anticipative system, as the output does not anticipate future values of the input. For example, the motion of an automobile is causal since it does not anticipate future actions of the driver. Causality is a necessary condition for a system to be built in this real world. Causality is important for communications and control systems that operate in real time. There are applications that non-require real-time processing in speech, geophysical, or meteorological data processing system. Basically, what we are going to do over here, we are storing that data and we will be processing that data later. So here it is, the causal system is not required for processing such type of signal. Causality is also not important for image processing system, in which independent variable is not a time, right? Therefore, non-causal system can be used for non-real-time systems. For real-time systems, we will be using a causal system, but for non-real-time system, we may use a non-causal system. Example, here one example is given, yt is equals to xt plus 1. You can see over here the output yt is dependent on the future value of the signal. Therefore, this type of signal is a non-causal system, right? Here one example of moving average filter is given over here, and we have to find whether it is a causal system or non-causal system. For the sake of simplicity, let us take the value of m equals to 1. So if we will substitute m equals to 1, we will be getting this yn equals to 1/3 of x of n minus 1 plus xn plus x of n plus 1. And if we look into this expression, very easily we can see that this is requiring the future value of the input signal, and therefore this system is a non-causal system. Okay, so a system is said to be causal if the output of the system at any time depends on the present as well as the previous values of the input. So in mathematical term, we can define a causal system in which output is function of the present as well as previous values of the input, right? And if a system is dependent on the future values of the system, that system is said to be a non-causal system. Examples are given over here. Let us take this first system. Yn is equals to summation k is equals to 0 to n hk x of n minus k. If we look into this system, this is dependent on the since the value of k is ranging from 0 to n. So the value of x of n minus k will start from x of n minus 1 up to x of n minus n. So the present value as well as the previous values of the inputs are required and no future value is being considered over here. Therefore, this system is a causal system. Another example is given over here. This one. Let me clear the screen first. Yeah. If we consider the second system, the expression for which is given over here, you can see here, this is dependent on the present value of the input. This is dependent on the previous value of the input. Therefore, this system is a causal system. So both of these systems given over here are causal system. Taking another example here, this is dependent on the future value of the input. Hence, this system is a non-causal system. Taking another example, here yn is equals to the value of k is ranging from minus 10 to 10 and x of n minus k. If you look into this value, you can see here that this expression is very much similar to this expression. Only for here the value of k is ranging from 0 to n, whereas here we have considered the value of k from minus 10 to plus 10, right? So if we look into x of n minus k, it will be x of n plus 1, x of n plus 2 up to x of n plus 10, then x of 0, then x of n minus 1, x of n minus 2 and up to x of n minus 10. So this is the present value of the input. These are the previous values of the input, but these are the future values of the input. Since the output of this system is dependent on future values of the input, therefore this system is considered to be a non-causal system. Right? So I think this is all for today. Tomorrow we will start with the other properties of the system. Thank you very much.